Welcome to my video course on engineering FMRCs. We are diving into one of the most fascinating engineering puzzles in modern rail right now. We're talking about bridging the massive gap between legacy communication systems and the fully digital future of railways. It's all about how we keep trains moving safely and reliably into a new era of broadband connectivity, ensuring that critical operations literally never skip a beat during this massive technological leap. Here is our roadmap for today. We'll kick things off with an introduction to FRMCS Transition, then look at the roadblocks to 5G adoption. After that, we'll unpack the FRMCS strategy, dive into leveraging 4G EPS architecture, and wrap up by looking at how we're actually running critical rail services. All right, Section 1, Introduction to FRMCS Transition. So, for decades, railways everywhere have been leaning heavily on a legacy communication standard called GSM-R. You know it, it's been a total workhorse. But let's face the stark reality here. GSM-R is reaching the end of its life. It's officially facing predicted obsolescence. And the crazy thing is, this is happening right at the exact same time that train control systems like ETCS are living longer, and the operational demands on modern railways are just skyrocketing. The railway of tomorrow? It's all about data. Heavy, real-time data. And our old 2G-based networks, there is just no way they can handle that kind of traffic. This creates a massive, absolutely urgent push toward a true broadband successor, the Future Railway Mobile Communication System, or FRMCS. Moving right along, Section 2, Roadblocks to 5G Adoption. Now, you might be wondering, hey, why don't we just flip a switch to 5G everywhere tomorrow? Well, I wish it were that easy. While a 5G standalone architecture is absolutely the dream destination for FRMCs, we have some very real tangible barriers in our way right now. First off, the required 5G spectrum is either entirely unavailable in a lot of regions or comes at a tremendously high cost. On top of that, railways cross borders all the time, right? But different countries are on entirely different timelines for rolling out 5G, which is a massive headache for synchronization. Throw in early constraints for migration and intense time-to-market pressures, and we've got a serious bottleneck. Basically, railways literally cannot afford to wait around for full 5G maturity to begin upgrading those dying GSM-R systems. Which brings us to our next part, Section 3, the FRMCS-T strategy. Okay, let's really zero in on this definition, because this right here is the absolute core of our lecture today. FRMCS Transition, or FRMCS-T, is a highly specific technical framework. What it does is facilitate the application of FRMCS standards over existing 4G networks. Think of it as an official stepping stone. Actually, scratch that. It's the essential bridge we need right now. Since we can't wait for all those 5G roadblocks to magically clear up, FRMCS-T lets the industry push forward immediately. It gives us the exact parameters to run next-generation railway communication on mature, existing 4G infrastructure, ensuring modernization doesn't stall out just because we're waiting for 5G spectrum. Let's look under the hood. Section 4, Leveraging 4G EPS Architecture. To really grasp why FRMCS-T is such a game changer, we need to draw a direct engineering parallel between 5G and 4G. Now, 5G gets all the hype for its native, all-IP, packet-switched architecture, right? And that's absolutely crucial for handling ultra-reliable, low-latency communication. But here is the secret sauce. 4G EPS, the Evolved Packet System, is the direct predecessor to 5G. And guess what? It also utilizes an all-IP-based architecture. Because 4G EPS is already globally deployed, stable, and completely mature today, its all-IP nature makes it practically tailor-made to transport the exact same data packets that our future 5G network will carry. And this brilliantly illustrates the elegance of this whole approach. Leveraging 4G EPS provides an incredible level of future-proofing. Right now, out in commercial use, a ton of 4G network devices can actually upgrade to 5G entirely via software changes, no hardware rip and replace required. By using 4G EPS as the transport layer for FRMCS today, railways maintain a completely seamless upgrade path. When that 5G spectrum finally becomes available and cost-effective, networks can transition over without facing a massively disruptive, ground-up hardware overhaul. If we break down the architecture of the FRMCS Lite system, you'll notice it is split into 3 distinct layers. Down at the bottom, you've got the transport stratum. For us right now, that is our trusty 4G EPS network, providing the raw connectivity and managing multiple radio access technologies. Sitting right above that is the service stratum, taking care of critical signaling and network management. And then, at the very top, interfacing securely with the rest, is the railway application stratum. This architectural separation is absolutely vital. It means the application actually running the train doesn't need to care if the transport layer underneath is currently 4G or 5G. The service stratum handles all the translation, allowing secure, reliable data flow regardless of the underlying radio infrastructure. And finally, let's talk about the applications. Section 5. Running critical rail services. So, we know the transport stratum carries the data, but how do we make sure life-saving rail operations get top priority and total security? That is exactly where Mission Critical Services, or MCX, come into play. These are essential 3GPP standardized protocols built specifically to run highly reliable railway operations over mobile broadband. Now here is the kicker. These MCX services have actually been standardized since 3GPP Release 13. What does that mean for us? It means they are fully supported and completely manageable by today's 4G systems. You literally do not need a 5G network to run mission-critical services. 4G EPS is already 100% equipped to handle the heavy lifting. Let's walk through how a network executes this transition step by step out in the field. Step 1. You deploy the 4G Evolved Packet System as your foundational transport stratum. Step 2. Out goes the old GSM-R voice radios, and you implement Mission Critical Push-to-Talk, or MCPT. This handles all those bulletproof voice communications between drivers and controllers. Step 3. You integrate MC data, which takes over secure telemetry and critical train signaling flows. And finally, Step 4. You prepare for MC video, unlocking high-bandwidth capabilities for live onboard surveillance and remote monitoring. Piece by piece, legacy functions are modernized and expanded using these distinct layers. When you stack all this architecture together, the capabilities you unlock are honestly amazing. This FRMCS-T setup running over 4G successfully supports the brutal, data-intensive demands of modern rail. We're talking about advanced voice services, seamless European train control system data flows keeping trains safely separated, high-speed telemetry for automatic train operation, and live onboard video surveillance. Every single one of these demands strict packet reliability and super low latency, and this architecture proves beyond a shadow of a doubt that we can support these next-gen requirements right now simply by leveraging 4G apps. So I'll leave you with this final, thought-provoking engineering puzzle to consider. With FRMCS-T giving us this incredibly robust, software-upgradable 4G stepping stone today, how will your specific network handle the final 5G transition when the time eventually comes? Thanks, we can see you next video.